My name is Peter Dueben from the European Centre for Medium Range Weather Forecasts, ECMWF, and I'm leading the work package 2 on community tools in ESiWACE3. ESiWACE basically has a responsibility to enhance the European weather and climate community to make the best use of Europe's high-performance computing and supercomputing facilities in the future. To do this, this work package is now looking into what we call community tools. So it's basically that we develop different tools that will help specific aspects of the high-performance computing community to kind of really make the most out of the future machines. In particular, we're always bringing in the three different branches that we have. We're bringing in two partners that have kind of fairly similar, agendas basically, but independent tool developments, and we're bringing them together to generate synergies between the different partners. The first branch that we're looking into is what we call reduced numerical precision. And the idea here is that if you represent numbers in a supercomputer, you basically do this with bits. And the more bits you have, the more precise the number is going to be, but also the more expensive the calculation is going to be in the end. If we can reduce numerical precision, we can kind of speed up our calculations and get, eventually better results as we can basically increase resolution, for example, or run more simulations. And here we're bringing together basically two tools from the community to really explore how you reduce the precision best in those very complex applications that we have, and also this kind of chaotic environment that we have in weather and climate simulations, which is typically non-trivial to basically find then the optimal level of precision. In the second branch, we're looking into what we call domain-specific languages. And the idea here is that it's normally very difficult actually to kind of port those very large compute codes onto specific supercomputers. In particular because the hardware is now getting more and more heterogeneous in a sense that we basically have more and more different hardware types on the different supercomputers. And the domain-specific language is basically trying to help domain scientists to kind of formulate the code in a fairly easy environment and then help computer scientists to kind of take this code and kind of optimize it for a specific supercomputer. Again, we're bringing together kind of two branches of DSL developments, domain-specific language development in Europe in this work package, and to optimize kind of the two different branches together and to generate synergies. And the last part that we're looking into is actually what we call performance optimization. So if you have a specific code and you really want this code to run as fast as possible on a specific hardware, it's actually also like quite a difficult task to really kind of generate the best possible setup in the end. The idea here is again that you have tools that can do this for you, so that the tools will basically help you to adjust your model component or your part of a model in a sense that you can really know which operation you should actually kind of perform in which order, and also how you could basically structure the data in the best possible way. And there are again two different approaches to do this, and in the work package we'll bring them together to generate synergies between two of the partners that are kind of have a lot of expertise in the performance optimization to get the best possible results in the end, and also basically to enhance the capabilities of those tools when applied to weather and climate models in Europe.